In this lesson, we're going to talk about parallel lines. We're just going to refresh your memory, some geometry memory, and see how it kind of incorporates into trig a little bit. So basically, we just got to know some information from geometry. So if you have parallel lines, you're going to have a couple different situations, a couple different relationships. The two things you're going to have is either angles equal each other or they add up to 180. So here are your situations. So if you have corresponding angles would be you have a group of 4 angles here, you have a group of 4 angles here. Angle 1 and angle 5 are corresponding angles. They're in the same location out of the group of 4. So this is kind of in your upper left, this is in your upper left. So 1 and 5 are going to be equal to each other. Corresponding angles are equal. So 1's equal to 5, angle 2 and 6 would be equal to each other, 3 and 7, 4 and 8. So all those angles would be equal to each other. Alternate interior and exterior angles are also equal to each other. That would be alternate interiors would be 3 and 6. They need to be opposite sides of this line passing through. So 3 and 6 are equal to each other, 4 and 5 are equal to each other. 1 and 8 would be alternate exteriors, 2 and 7 would be alternate exteriors, so they would be equal to each other. The last piece of them equaling each other is vertical angles, which actually don't have anything to do with parallel lines. They are just in this group of 4. 1 and 4 are across from each other, 2 and 3 are across from each other. They're equal to each other. So it doesn't have anything, these don't relate to these are just across from each other are equal, 2 and 3 are equal. So 5 and 8 are equal, 6 and 7 are equal. So those are all the equal relationships that you have. You also have same side interior, same side exterior angles, and they're supplementary. So you have angle 3 and 5 are on the same side and they're in the interior. They're going to be supplementary to each other, which means angle 1 and angle 3 add up to 180. 4 and 6 would add up to 180. Same side exteriors are 1 and 7. So 1 and 7 would add up to 180. 2 and 8 would add up to 180. So how might you see that at the beginning of trig? You may have some sort of question like this, where it says find angle 1, angle 2, angle 3, and angle 4. So let's say you have a picture like this. This is angle 1, angle 2, angle 3, and angle 4. And you are given that angle 1 is 3x plus 2. And you're given angle 4 is 5x minus 40. So you just got to figure out which situation do you have. So we have angle 1 and angle 4, so either they're going to equal each other or they're going to add up to 180. So 1 and 4 are alternate exterior angles, alternate exteriors, so they're equal to each other. So that means we can take 3x plus 2 and set it equal to 5x minus 40 and solve. So I'm going to take the 3x and bring it over to the 5x to keep my variables positive. So at the same time, I'm going to take the 40 and bring it over to the left. So I get 2x equals 42. Divide by 2. X equals 21. But that's great, but it wasn't exactly what we were looking for. So if x is 21, we can take the x and plug it into here. So if we plug in 21 into here, we're going to get a 63 plus 2. So that puts us at angle 1 equal to 65 degrees. And then angle 3 and 1 are vertical angles. So if this is 65, that puts that at 65. So angle 3 would equal 65 degrees. And then we already started the thing with these two are going to be equal to each other. So if this is 65, 4 is going to be 65. And then if 2 is what we're missing, so angle 2 is a lot of different ways to look at this. These two angles make a straight line, so they have to add up to 180. These two angles make a straight line, so they have to add up to 180. You also have same side exteriors, which makes those two add up to 180. So a lot of different ways to figure this out, but basically we're going to take 180 minus 65, and we're going to get 115 for angle 2. And that was parallel lines.